Professor Naxos adjusted his third eye lens as he gazed at the fresh batch of navigation students filing into the grand calculation chamber of the Galactic Navigation Academy. His tentacles twitched with anticipation, or perhaps it was anxiety. After all, this was the most prestigious educational institution in the known universe, and these students represented the brightest minds from 17 different species. "Welcome, future navigators, to Advanced Route Calculation 401, he announced, his voice resonating through the chamber. "I am Professor Naxos, and I will be your guide through the intricate art of interstellar pathfinding." The chamber itself was a marvel of engineering, with holographic star maps spinning lazily overhead and quantum computing terminals at each student's station. The ceiling arched hundreds of meters above, designed to accommodate species of all sizes, from the towering Proxians to the diminutive Zeta Minors. Now Professor Naxos continued, bringing up a complex series of equations on the main display. "Who can tell me the standard time required to calculate a safe route between two star systems?" A student from the Centaurian collective raised all four of their appendages. "7 standard cycles, Professor. 1 to account for gravitational variables, 2 for quantum fluctuations, 3 for dark matter density mapping, and 1 for final verification." "Excellent, student Lyra. Though you forgot to mention the mandatory rest period between calculations. We wouldn't want another Epsilon incident, would we?" A nervous chuckle rippled through the chamber. Everyone knew about the navigator who had attempted to calculate a route while sleep-deprived and ended up plotting a course through a neutron star. Professor Naxos glided to his central podium, his hover pads humming softly. The role of a navigator is perhaps the most crucial in our modern spacefaring society. 1 miscalculation, 1 decimal point out of place, and entire ships can be lost to the void. This is why we take a full week to plot each new route. He gestured to the Wall of Honor, where holographic images displayed the Academy's most distinguished graduates. These individuals have saved countless lives through their dedication to precise calculation. Some of them spent up to 3 standard months plotting single routes through particularly challenging sectors. The students watched in awe as he brought up a simulation of a failed route calculation. The projected starship crumpled as it hit an unexpected gravity well. This is why we maintain our rigorous standards. This is why the Academy accepts only the top 0.001% of applicants. This is why our certification process takes 15 years. A quiet murmur of appreciation swept through the chamber. Many of these students had spent their entire lives preparing for admission to the Academy. Some species started their children on calculation exercises practically from birth, all hoping to secure one of the coveted navigation positions that kept interstellar society functioning. Today, Professor Naxos announced, his tentacles spreading wide in an expression of ceremonial importance, "We begin your journey into advanced cartography and multidimensional route mapping. By the end of this term, each of you will be expected to calculate a route through the Rigel sector, with all its notorious quantum disturbances in under 2 weeks." The students straightened in their seats, data pads ready, neural interfaces humming. This was what they had come for. This was the moment their lives would truly begin. What none of them knew, not even Professor Naxos, was that everything they understood about navigation was about to change, but that would come later. For now, they had algorithms to memorize and equations to perfect, each one a small step toward mastering the art of guiding ships through the infinite darkness of space. Professor Naxos looked at his class one final time before beginning the lesson proper. "Now, let us start with the basics of 11-dimensional space-time curvature calculations." The next morning, Professor Naxos noticed something unusual in the grand calculation chamber. Among the familiar sight of tentacles, appendages, and neural interfaces, there sat a figure that looked almost unsettlingly simple. 2 arms, 2 legs, and only 1 head with a single pair of eyes. A human. "Ah, you must be the transfer student," Professor Naxos said, hovering closer. "Amanda Pierce, correct?" "Yes, Professor," she replied, sitting at her station with nothing but an old-fashioned paper notebook and what appeared to be a primitive mechanical calculating device. Several of her classmates craned their various sensory organs to stare at her archaic tools. Student Lyra leaned over to their Proxian neighbor. "Where is her quantum interface? How does she process gravitational matrices without a neural link?" "I heard humans can only think in 3 dimensions," whispered another student, their crystalline form shimmering with barely contained amusement. Professor Naxos raised 3 of his tentacles for silence. "Miss Pierce comes to us from the Earth Space Navigation Institute. While their methods may seem unconventional, they have successfully guided ships through some of the most challenging regions of space." Amanda smiled politely, though her eyes betrayed a hint of determination. She had heard all the whispers before, seen all the sideways glances. She was used to being underestimated. "Now then," Professor Naxos continued, "today we will be calculating a route through the Carina Nebula. Please access the quantum data streams and begin your preliminary gravitational surveys." The chamber filled with the soft hum of neural interfaces powering up. Holographic displays sparkled to life as students began their calculations. Meanwhile, Amanda pulled out something that made several of her classmates gasp in horror: a simple pencil. "Miss Pierce," Professor Naxos said, trying to keep his tone neutral, "the standard calculation procedure requires." "With respect," Professor Amanda interrupted, "I have clearance to use Earth methods." She pulled out what looked like a brass instrument with graduated markings. "This is a sextant. We use it for celestial navigation." "A mechanical device?" For stellar cartography student Lyra's voice modulator crackled with disbelief. "That is like using a stone tablet to solve quantum equations." "Miss Pierce," Professor Naxos said, his tentacles twisting in concern, "while we respect diverse cultural approaches, the Academy has certain standards. The calculations for nebula navigation alone take 3 days of constant neural processing." Amanda looked up from her notebook, where she had already filled several pages with quick, precise notations. "On Earth, we have a saying, sometimes the old ways are the best ways." The class descended into barely contained laughter. Even Professor Naxos's third eye twitched with what might have been amusement or concern. "Very well," he said finally. "You may proceed with your method. But I must warn you that falling behind in this class is not an option. Lives depend on our calculations being perfect." As the morning progressed, students immersed themselves in their neural interfaces, processing vast amounts of data. Meanwhile, Amanda worked steadily with her sextant and notebook, occasionally glancing at the holographic star map overhead, making quick adjustments to her calculations. During the lunch break, she sat alone, continuing to work while others networked their minds together in the traditional social circles of the Academy. Student Lyra approached her, curiosity finally overcoming their skepticism. "How do you compensate for quantum fluctuations without a neural processor?" they asked, genuinely puzzled. Amanda looked up from her work. "We don't always need to. Sometimes the simplest solution is the best one. Would you like me to show you?" Before student Lyra could respond, Professor Naxos called the class back to order. As everyone returned to their stations, Amanda noticed several students giving her calculating looks. She had seen that expression before on Earth, during her training. It was the look people got just before they realized they might need to rethink everything they thought they knew. She smiled to herself and returned to her calculations. The real surprise was still to come. 2 weeks into the term, Professor Naxos made an announcement that sent ripples of excitement through the grand calculation chamber. "Students, the annual Interstellar Navigation Championship approaches," he declared, his tentacles arranged in the formal announcement position. "For those unfamiliar, this competition determines the finest navigation minds in the galaxy. The challenge? Plot a safe route through the notorious Maelstrom sector." Holographic displays flickered to life, showing a chaotic region of space where 3 black holes danced an eternal gravitational waltz. Solar storms raged between them, while quantum anomalies sparkled like deadly fireworks. "The winning team," Professor Naxos continued, "will receive an automatic placement at any navigation post in the United Galactic Systems. Last year's winners now plot routes for the presidential fleet." The chamber erupted in excited chatter. Student Lyra's crystalline friend, Nova, sparkled with anticipation. "My parent cluster spent 3 years calculating routes through the Maelstrom. They said it was like trying to thread a needle during an earthquake." Amanda studied the holographic display intently, her hand moving across her notebook. Instead of the usual equations, she was drawing what appeared to be a star chart. "Teams will have access to our most advanced quantum computers," Professor Naxos announced. The Archimedes array has been reserved exclusively for competition preparation. I expect our class to maintain the Academy's prestigious record. The next few days transformed the Academy into a hive of frenetic activity. Teams formed quickly, students clustering based on compatible neural frequencies. The Proxians merged their consciousness into a single navigation entity. The Centaurian collective linked their four-dimensional minds into a living quantum computer. Amanda sat alone, surrounded by star charts and what looked like weather predictions. She had requested access to historical navigation records, particularly those of ancient seafaring vessels from Earth. Miss Pierce Professor Naxos approached her study area, concern evident in all three of his eyes. The competition requires team participation. Surely you don't intend to enter alone. Actually, Professor, she looked up from a diagram of ocean currents. I was hoping to partner with student Lyra, if they're willing. Across the chamber, student Lyra's appendages twitched in surprise. They had been watching Amanda's unusual preparations with growing curiosity. But my neural interface isn't compatible with human thought patterns, Lyra protested. Amanda smiled. We won't need neural interfaces. I want to show you something that might change your perspective on navigation. Over the next few days, an unusual sight became common in the Academy's stellar observation dome. Amanda and Lyra spent hours there, with Amanda pointing out patterns in the star fields and drawing parallels between ocean navigation and space travel. See how the gravitational eddies follow similar patterns to ocean currents. Amanda traced a path through the holographic display. Ancient sailors used these patterns to navigate Earth's oceans centuries before computers existed. But the maelstrom is three-dimensional, Lyra argued. The gravitational forces alone require days of computation. True, Amanda conceded. But what if we're making it more complicated than it needs to be? Look at this. She pulled up a historical image of Polynesian sailors navigating by the stars. These people crossed vast oceans without any instruments more sophisticated than the stars themselves. While other teams immersed themselves in quantum calculations, Amanda taught Lyra to use a sextant. They studied gravitational wave patterns like ancient sailors studied water currents. They mapped stellar positions and magnetic field lines, treating the maelstrom like a particularly challenging stretch of ocean. The principles are the same, Amanda explained, showing Lyra how to take stellar readings. Space, like the ocean, has its own rhythms and patterns. We just need to learn to read them. Professor Naxos observed their preparations with increasing interest. He had never seen such an unorthodox approach to navigation. By all traditional measures, it should have been doomed to failure. Yet something about Amanda's confidence made him wonder. The night before the competition, while other teams were still deep in neural link calculations, Amanda and Lyra stood in the observation dome, looking at the actual stars rather than holographic projections. Do you really think we can navigate the maelstrom using these ancient methods? Lyra asked, their appendages nervously adjusting their ceremonial competition robes. Amanda pointed to a particularly bright star. You know what sailors on Earth called the North Star? They called it the steadfast star, because no matter how rough the seas got, no matter how lost they felt, that star would always guide them home. She turned to her partner with a grin. Tomorrow, we're going to show everyone that sometimes the best technology isn't technology at all. Sometimes it's just about knowing how to read the signs that have always been there. As they left the dome, other competitors watched them with a mixture of pity and amusement. After all, how could anyone hope to navigate the maelstrom without quantum computers? What chance did ancient methods have against modern technology? They were about to find out. The competition arena dwarfed even the grand calculation chamber. Hundreds of species filled the observation galleries, their excited chatter creating a symphony of clicks, whistles, and electromagnetic pulses. Holographic displays showed the maelstrom sector in terrifying detail, its three black holes writhing like hungry predators. Welcome to the 457th Annual Interstellar Navigation Championship, announced Supreme Navigator Telos, their voice resonating through the arena. Today's challenge: plot a safe route through the maelstrom sector, suitable for a fleet of colony ships. The competing teams took their positions at navigation stations arranged in a circle around the central hologram. The Proxian team had merged into a pulsing mass of neural tissue, their combined consciousness already processing gravitational variables. The Centaurian collective's four-dimensional minds expanded into higher planes of mathematics. Amanda and Lyra's station looked almost empty in comparison. No neural interfaces, no quantum processors. Just a brass sextant, a stack of paper, and a mechanical calculator that looked like an antique toy next to the advanced technology surrounding them. The parameters are as follows. Supreme Navigator Telos continued. The route must accommodate ships up to Class 7 size. Survival probability must exceed 99.9%. Time limit 1 standard week. Professor Naxos watched from the judges' panel, his tentacles twitching nervously as he observed his students. The team from the Rigel Institute had brought their own quantum computer array, its crystalline structure humming with raw computational power. Begin. The arena erupted into activity. Neural interfaces lit up like festival lights. The Proxian mass expanded, absorbing data streams directly from the holographic displays. The Centaurian collective split their consciousness across 11 dimensions, analyzing quantum fluctuations in real time. At the human alien station, Amanda stood up and walked to the center of the arena. The audience murmured in confusion. Competitors weren't supposed to leave their stations during calculations. "What is she doing?" Professor Naxos whispered to a fellow judge. "The gravitational data feeds are at the stations." Amanda raised her sextant to the holographic display, taking measurements as if she were on the deck of an ancient sailing ship. Lyra followed her lead, using their appendages to mark positions on their star charts. "Look at the primitive creatures," sneered the Rigel team leader, their crystalline form vibrating with amusement. "They're treating space like an ocean." Hour after hour passed. The Proxian mass grew larger, processing countless variables. The Centaurian collective's calculations spanned mathematical dimensions beyond normal comprehension. Quantum computers hummed, neural networks pulsed, and data streams flowed like rivers. Meanwhile, Amanda and Lyra moved around the hologram, taking measurements, consulting their charts, and making quick calculations on their mechanical device. They worked with a fluid grace that seemed almost like a dance. "Notice how the gravitational waves flow between the black holes," Amanda pointed out to Lyra. "Just like ocean currents between islands. And see that pattern of solar flares? They follow the same cycles as trade winds on Earth." Lyra's appendages moved rapidly across their charts. "The quantum fluctuations. They're not random at all, are they? They follow the gravitational tides." "Exactly. Space has its own weather patterns. We just need to learn to read them." Supreme Navigator Telos approached their station, confusion evident in their multifaceted eyes. "Your methods are unconventional. How do you account for 11-dimensional variables without quantum processing?" Amanda smiled. "We don't need to. The same way ancient sailors didn't need to calculate every wave to cross an ocean. They learned to read the patterns, to work with nature instead of trying to compute every variable." The first day passed. Then the second. The Proxian mass had grown to fill half their station, their combined minds wrestling with quantum mechanics. The Rigel team's crystal computer glowed with the heat of its calculations. On the third day, something extraordinary happened. Amanda looked up from her charts, turned to Lyra, and nodded. They gathered their materials and approached the judges' panel. "Impossible," muttered one of the judges. "They can't be finished. It's only been 3 days." Professor Naxos leaned forward, all 3 eyes focused intently. "You're submitting your route already?" "Yes," Professor Amanda said, spreading out their charts. "We found a safe passage through the maelstrom. Would you like us to demonstrate?" The arena fell silent. The Proxian mass quivered in disbelief. The Centaurian collective paused their calculations across all 11 dimensions. Supreme Navigator Telos activated the main holographic display. "Very well. Show us your route." Amanda and Lyra worked together, inputting their coordinates into the simulation system. The holographic display zoomed in on the maelstrom, and a glowing path appeared between the black holes. "You see this gravitational eddy here?" Amanda pointed to a spot where the black hole's forces intersected. "It creates a stable corridor, like a river flowing between mountains. If we time our passage with the solar flare cycles, we can ride the gravitational current straight through. The simulation began. The virtual colony ships followed the plotted route, sliding smoothly through the chaos of the maelstrom. They rode the gravitational waves like surfers on Earth's oceans, using the very forces that made the sector dangerous to propel them safely through. By working with the natural flows of space, Lyra explained, their appendages moving excitedly, we don't need to calculate every quantum variable. The path is already there, we just needed to see it. The simulation completed. Survival probability 99.97%. The arena erupted in shocked whispers. The Rigel team's crystal computer cracked slightly in surprise. The Proxian mass rippled with disbelief. Professor Naxos stared at the results, all three of his eyes wide with astonishment. In 3 days, you found a route that would have taken our computers weeks to calculate. How? Amanda held up her sextant with a smile. Sometimes the best technology isn't technology at all. Sometimes it's just about learning to read the stars. The competition arena had transformed from a place of focused calculation into a hub of bewildered excitement. Supreme Navigator Telos called an immediate conference of the judges while the other teams abandoned their calculations to gather around Amanda and Lyra's station. Please, Professor Naxos said, his tentacles trembling with barely contained curiosity, explain this method to us in detail. Amanda picked up her sextant, holding it out for all to see. This instrument was first used by humans thousands of years ago. Before we had computers, before we even had electricity, we crossed vast oceans using nothing but the stars as our guide. But space is different from oceans, protested the Rigel team leader. The mathematics alone are simpler than you think, Amanda interrupted gently. You see, humans learn navigation by necessity. We didn't have natural spatial awareness like the Proxians or multidimensional thinking like the Centaurians. We had to learn to recognize patterns. She pulled up a holographic display of Earth's oceans. Our ancestors noticed that ocean currents followed predictable patterns. They learned to read weather signs in the sky. They passed this knowledge down through generations, not as complex equations, but as observable truths. Lyra stepped forward, their appendages moving excitedly. When Amanda showed me how to look at space like an ocean, everything changed. The gravitational waves between stars are just like ocean currents. Solar winds follow patterns like trade winds on Earth. Even quantum fluctuations have rhythms you can learn to predict. The Proxian mass rippled with skepticism. But our calculations show it takes at minimum 3 days to process gravitational variables alone. Amanda smiled and walked to the central hologram. Watch this. I'll plot a new route, right now. The arena fell silent as she raised her sextant to the star field. Her movements were quick, precise, almost like a dance. She consulted no computers, ran no quantum simulations. Instead, she moved around the hologram, taking measurements and making rapid notes. There she said after just 15 minutes, drawing a line through the holographic maze of gravitational forces. A safe route through the Antares Nebula. Professor Naxos quickly input her coordinates into the verification system. The simulation ran, showing a perfect path through the chaos. The survival probability calculator spun up to 99.99%. Impossible, whispered the Rigel team leader. No, Amanda said, just different. Humans have always been good at finding shortcuts, at seeing simple solutions to complex problems. We had to be. We couldn't process 11 dimensions in our heads or merge our minds with computers. We had to learn to work smarter, not harder. She projected an image of ancient Polynesian sailors navigating by the stars. These people crossed the largest ocean on Earth without a single piece of advanced technology. They learned to read the waves, the winds, the stars, and even the patterns of seabirds. They understood that nature itself provides all the navigation tools we need, if we just learn to read them. The Centaurian collective hummed thoughtfully. But how do you account for quantum uncertainties? Lyra answered this time, their training with Amanda evident in their confidence. We don't need to calculate every quantum fluctuation. Just like ancient sailors didn't need to calculate every wave. They learned which patterns mattered and which ones they could work around. Think of it this way, Amanda added. When you're walking, do you calculate the exact force needed for each step? The precise angle of your leg? The impact velocity of your foot? No, you learn the pattern and your body follows it naturally. Space navigation can work the same way. The revelation rippled through the arena like a shock wave. Centuries of increasingly complex calculations, more and more powerful quantum computers, neural interfaces that could process 11 dimensions simultaneously. And here was a method that required nothing more than careful observation and understanding. Supreme Navigator Telos floated forward, their ancient form crackling with energy. In all my centuries of navigation, I have never seen anything like this. You've taken us back to basics in a way that pushes us forward. Professor Naxos's tentacles had stopped twitching, now arranged in a pattern indicating deep thought. All this time, we've been so focused on calculating every variable that we forgot to step back and look at the bigger picture. Amanda nodded. The stars have been guiding travelers for as long as there have been travelers to guide. We just needed to remember how to listen to them. The Proxian mass had begun to shift color, a sign of profound paradigm shift in their species. The Rigel team's crystalline form sparkled with new understanding. Even the Centaurian collective had shifted their perception to better grasp this elegantly simple approach. Sometimes, Amanda said, holding up her sextant, the old ways are the best ways. Not because they're old, but because they're true 6 months after the competition. The grand calculation chamber looked very different. Where once there had been only neural interfaces and quantum computers, now students gathered around traditional star charts. Sextants glinted alongside holographic displays, and the sound of mechanical calculators mingled with the hum of advanced technology. Professor Naxos watched with pride as Amanda led a mixed group of students through a navigation exercise. The Proxian mass flowed smoothly around a star chart, while Centaurian appendages traced potential routes through space. Even the Rigel students had adapted their crystalline forms to better handle traditional navigation tools. Remember, Amanda said to her group, every species brings its own strengths to navigation. The Proxians' natural spatial awareness makes them excellent at reading gravitational currents. The Centaurians can visualize complex routes in ways humans never could. We're not replacing the old methods, we're combining them. Student Lyra, now a teaching assistant, demonstrated to a group of newcomers how to use quantum calculations to verify routes first plotted by traditional methods. Think of it as a partnership between intuition and computation. We use the stars to find the path, then use technology to perfect it. The Academy's curriculum had been completely revamped. New courses like traditional celestial navigation and pattern recognition in spatial phenomena were now required alongside the standard quantum mathematics. The average time for plotting complex routes had dropped from weeks to days, sometimes hours. Supreme Navigator Telos visited regularly, watching with satisfaction as students from 17 species learned to navigate using both ancient wisdom and modern technology. They had even started carrying a sextant alongside their neural interface. The true breakthrough, Professor Naxos explained to a group of visiting dignitaries, wasn't just in faster calculations. It was in understanding that different approaches could work together. The human gift for pattern recognition, combined with our computational power, has revolutionized space travel. Amanda's navigation method had spread beyond the Academy. Commercial shipping companies reported fuel savings of up to 40% using the new combined approach. Exploration vessels ventured into previously impassable regions by reading space like ancient sailors read the seas. But perhaps the most significant change was in the students themselves. Species that had once competed now collaborated, each contributing their unique perspectives and abilities. The Proxians taught others about intuitive spatial awareness, while the Centaurians shared their insights into multidimensional thinking. Humans, with their gift for seeing simple solutions to complex problems, helped bridge the gap between instinct and computation. One day, as the last class was ending, Professor Naxos found Amanda in the observation dome, teaching a young Proxian how to use a sextant. "You've changed everything," he said, his tentacles arranged in a pattern of deep respect. Not just navigation, but how we think about working together. Amanda smiled, adjusting the sextant's angle. We all had pieces of the puzzle. Humans could read the stars, Proxians could feel space itself, Centaurians could see in 11 dimensions. We just needed to learn from each other. She pointed to a distant star, bright and steady in the darkness of space. You know what my instructor on Earth told me? She said that no matter how far we travel into space, the principles that guided our ancestors will guide us still. We just have to remember to look up and see the signs that have always been there. Above them, the stars sparkled like ancient beacons, their light reaching across time and space to guide travelers, just as they always had and always would. ... According to given script of sci-fi story above, create 10 ultra-photorealistic, not cartoonist from the above story. All characters should look like the same in all images, must be 4000 HD images 16:9 and generate images of all the scenes and characters step by step by step by step.